Hello, lovely people. Today I will take you on a ride because I'm going to be overtaking a project that's going to take me a while to finish. So, the project is to recap this Alpine amplifier. Now, this amplifier, it's very old. So I did manage to find an Alpine catalog from the 1990s, and this is the amplifier that is featured. So it's 554. It is rated like 4 times 50 watts. Obviously, Alpines do a little bit more, but yeah, that's the amplifier. Now, when I bought it on eBay, and you can see it's filthy. It is in an extremely bad shape. So this amplifier is probably one of the worst that I ever bought. However, it was cheap. I paid like £60 for it. So inside, I just removed everything. It's filthy. I don't know where it was or what it did. You see all of this? Like, it is filthy. And when I opened it, because I do open all of the amplifiers that I buy, I found this one. So this cap, you can see this one, it's bulging. So these caps, they are already going bad. Now with amplifiers, most of the parts, everything is, I don't want to say lasts forever, but nothing can really go bad apart from the capacitors because they're electrolytic and the electrolytes can start leaking, or due to like heat and cold cycles, the caps go bad. So since this amplifier is close to like 35 years old, I'm not sure when it was produced. The only thing I have is this plate, which says that it is made in Japan. So I got it. Even with this bulging cap, I did measure it because what I want to do is I want to change all the capacitors and see how the performance of an amplifier changes. Now, as I mentioned, I measured it with my trusty Quantasylum, so all the measurements will be done with the Quantasylum QA403, and I got something like this. So this is THD versus level for all 4 channels. Now, I did loads of measurements, 7 measurements per channel, so a sine tone, intermodulation, multi-tone, THD versus level, THD versus frequency. I did check the channel separation. I did measure the output impedance so I can calculate the damping factor. I did everything that I can possibly do with this thing. And I got something like this, which you can see the THD versus power. It's the lowest it gets, 0.05. So for Alpine amplifiers, this is bad. You can see it's like 0.1, 0.5% over there, and then it goes into clipping. So surprisingly, it does quite a lot of power. Up to 1%, we're getting like 70 watts instead of 50. Alpines do a little bit more, but this performance is really bad. Now, how do I know? I have this one, which is very similar, 3.5 something. This is a 2-channel and it is a bit more powerful. So this that I got, it is in a much better shape, better condition. You see these caps, Nishikon caps, and everything looks kind of almost mint. And this amplifier, since they're kind of the same series, you have this remote plug, see the same, all the connectors the same, so they're from the same series. Kinda. And this amplifier measures like this. You can see the difference? This is 0.001. This amplifier is the cleanest amplifier that I ever have. So I know that this has potential. And I think that the reason for its bad performance is the caps, because there is no adjustable ports for biasing, so you cannot change the bias like on the fly. So the plan is, I have some isopropyl alcohol, so I will need to literally disassemble it, take it apart, and then literally clean the whole PCB, clean all of these, like literally clean everything. I'll need to get some thermal paste to replace it, and I will start swapping the caps. So I have all these caps already bought over here. So I did buy them from DigiKey and Farnell in the UK. And these caps, the ones that I tried to get, these black ones and blue ones, supposed to be Panasonic low ESR. I have some Nishikon Gold and Nishikon Muse. So basically I tried to get some good ones, not the cheap ones. So all of these. Now, since I never done this before, I ordered the parts and then I realized that I think this cap is a bit too big and I couldn't find the 40 volt, so I bought 50 volt and it is a bit too tall. So I don't know if I'm going to be able to close the lid, but it's going to be an experiment. Now on the board, on the PCB, if I'm going to zoom in, you can see all these caps are labeled. I guess 505, 507, this is E209. So what I did, I made a spreadsheet with all the caps. So I have all the numbers and all the values, volts and the capacity in microfarads. So these are all the capacitors that are in there. It was just for me to buy them because I didn't know what to buy. So I have all the caps. And the plan is, because I want to see how different parts of amplifier affect different things. So I am not an amplifier expert whatsoever. However, I did manage to figure some stuff out. So amplifier has a few different sections. I was watching a lot of bear vids, Sam Bernard on YouTube, so I kind of got it from him. So we have a power, which it goes here, that's the power terminals. Then you have inductors and transformers. I think this is inductor, this transformer. And then we have primary capacitors, where you have your 12 volts coming in. So these are rated at 16 volts. Then everything goes through this transformer, and this is a secondary capacitors. These are rated 40 volts. So we have that higher voltage to feed the transistors. So this one, this part is kind of the power supply part, if I'm gonna just do it like this. Then all of this side is where the signal processing happens. So this is your, I think it's called preamplifier circuit, because the RCAs, they're going through here, over these wires, they go in here, and then you have on this side all the high pass, low pass, gain, and everything. The crossovers are not adjustable, so it's just less stuff, but yeah, all the preamp stuff happening here. And then we have these transistors for the actual amplification. These on this side is for the power supply, and this is for the channels. So we have 4 identical channels, which is 1, 2, 3, 4, which has like all that stuff. And in the output side, we have just a few caps. So we have 1, 2, 3, 4, I think 4 caps per channel. And that's pretty much it. I think, I'm not sure probably this is for the signal as well, but I'm not sure. And then when everything goes out, because here on this side, you have all the speaker terminals and all the wires for the speakers are coming from here, from the middle of the board. So basically the signal goes in there, gets amplified here, and then it comes out and it goes there. So what I want to do is, I want to do it in sections. Because if I'm going to replace all the capacitors, I don't know what affects what. And what I want to see is where we're going to have the biggest difference in the measurements, where they're going to improve the most. So what I'm going to do is, first, I'm going to replace only capacitors for the 2 channels, this and this, or this and this probably, because I don't want to do it next to each other, because I think they're called like stereo pairs or something, because you have different crosstalk between these channels. So I'm going to replace this and this only, nothing else, and then I'm going to remeasure the whole set of however measurements I have and see if there's going to be any improvement. Then I'm going to replace the whole power supply. So we'll be replacing these, I would imagine, probably these small ones. I think they're in the power supply as well. I need to double check the traces. And after I replace the power supply caps, I'm going to remeasure again. And then I'm going to see if there's any difference between new power supply caps and new and old output caps. Is there going to be a difference between these? And after that, I will change everything in the preamp circuit as well, while I will still have 2 channels with these old caps. And then finally, after this, I'm going to replace the final 2, and then we're going to have basically all the amplifier recapped. And hopefully, we're going to see some improvement. While I'm going to be doing this, because since I have this list, I know all the caps, I know all the values. I bought this little thing, which is like a component tester. So you literally put any kind of component in it, and it tells you whatever that is and the value of it. Because old caps, they probably lose charge, probably they have higher resistance, and I want to see that. So if I'm going to take, for example, this capacitor, so this is supposed to be 2200 microfarads, 50 volts. It should be Panasonic low ESR. There's no marking on it, but that's what I bought. So if I'm going to stick it in there we go. It says capacitor 2189, so it's not 4, it's supposed to be 22, and we have 0.26 ohms. So I don't know if it's a low ESR. Again, I'm not an electrician, I don't fix amps, so I have no idea, but yeah, that's what I have. So what I'm gonna do is, when I'm gonna recap, when I'm gonna remove one cap, I'm gonna measure it, and I'm going to put the data in the spreadsheet, and we will see how much the values changed from the claim. I think it's going to be very interesting because I guess this cap, with the one that is bulging already, is going to have a very different value from the one that's stated on it. So I think it's going to be a very fun project, but it will take me a long time. With my workflow, when I'm not in a rush or anything, probably it's going to take a month or so, because like now I measured it, so all the caps are fully charged, so I need to wait for the heating to cool down, for the caps to dissipate the voltage, and only then I can start working on the board. And after every swap is exactly the same. Wait for the discharge, disassemble, put everything, assemble, and it's gonna take ages, but I think it's gonna be very fun. And if it's gonna be a success, I will have a very high quality amplifier for very cheap. I do not have any experience working with this. That's why I'm not gonna modify. I'm not gonna put different op amps. I don't know if this has op amps. Like I'm no professional. I'm not a technician. I have no idea what I'm doing. The only thing that I know is that I'm gonna take soldering iron, some solder, remove the cap, put a new one in, and that's it. So I am in the process of recapping this Alpine old school amplifier, and I am so stupid, and I'm literally fuming at myself. Let me tell you why. So this amplifier is like 90% recapped. I'm gonna show you later on. However, I want to show you something else. So I recapped the power supply, I retook the measurements as I was planning to do, I recapped all the signal path caps, I took the measurements, and everything is the same. So let me show you. If I'm doing just random measurements, I'm getting about 0.25, which is really high for this amplifier, and I cannot get any lower. I tried to measure after every single recap, and I'm getting exactly the same results. 0.24. Let me show you something. This is how stupid I am. Let me take this out. Let me take this out. That's one RCA. Let me put a different RCA. Bam. Bam. Reset. 0.0025. Everything go down. This thing, I was chasing ghosts for 2 weeks because of a bad RCA cable. Now, lesson learned, double check always your connections and everything, because after I've done almost everything and I was still getting bad results, I started to doubt myself. It's like, what the hell am I doing wrong? So actually, let me show you what I did. There we go. So you can see power supply caps, all brand new. This is brand new. All the signal path, brand new. I did replace only 2 of the outputs. So 2 of the outputs are old and 2 are new. I did this. I couldn't find anything. I was still getting everything bad. Then on Distortion Factory, somebody posted that when they were redoing old school amplifiers, what they do is, because a lot of times the pots, the gain pots are faulty, and he said he always replaces the gain pots with resistors, and then the noise goes away. I did exactly that. So this is for 2 channels, this is for the other 2 channels. So I removed the pot, I put on just resistors of a value that would give me like 4-volt gain, and I'm redoing the measurements, exactly the same. No change, no nothing. It's like, what the hell? So then I started, okay, maybe there's something like in the way. So I started obviously at the input side because I thought I couldn't imagine it's gonna be RCA. So I started to measure here because this is like literally RCAs out that going into the actual board. I wanted to measure these, but then I need the pins and everything. So I started to measure there and I'm getting a bad signal there. It's like, what the hell? So I removed the RCA and I measured RCA basically on loop back, in and out. And I know that thing is, this thing is super clean and it's giving me exactly the same 0.24. It's like, what the hell? I grabbed another RCA, everything is clean. So I'm literally fuming and I cannot forgive myself for making such a huge mistake. And now I'm thinking, because I don't remember with which RCA I was initially measuring this amplifier, because if I was measuring with this RCA and I got those bad results, that means that there's nothing wrong with the amplifier and it's just the RCA, and everything that I did was literally pointless. Well, kind of pointless. I did found two of the power supply caps that were bad. One that was bulging, it didn't read anything. Actually, let me show you. There we go. That's the one. So that's the one that was bulging, and it just took a reading 1800 nanofarads. So basically it doesn't read anything. 9 ohms. Yeah, it's literally the only bad cap in the power supply, and all the other ones, I did replace all the other ones because I have all of them here, you can see. So these caps, they're good. Like, I mean, quality wise, all of these are Rubicon and they're all good. All the values, I double checked, everything is fine. I thought maybe like these, the bigger ones will be faulty or so. Everything is fine. All the caps, exactly the same values, and all of them are low ESR, like below 1 ohm, 0.2, 0.3 ohms. So all the caps are totally fine, apart from one in the power supply. So basically all what I did was pointless, because everything came down to this one single RCA cable. So yeah, lesson learned. I will need to find smaller, these ones, I'm gonna put the old ones because there's nothing wrong with them, and these are much taller, so the lid doesn't close. But for the power supply, I will need to buy a bit shorter ones, maybe a bigger capacity as well, and resolder them again just to make sure that everything is closing down, because now this amplifier is working. So what I'm going to do now, I'm going to retake all the measurements. I'm going to publish in Distortion Factory. So yeah, let me do the measurements and we're going to go through them. So with this one, we're not going to start with the THD versus level. We're going to start with this one because I want to show you something. This is 1 kilohertz sine tone, and these are the harmonics. But what I want to point out is this one. So this spike at 18 kilohertz, 17.8, something like that, is from the power supply. And a lot of Alpine amplifiers have this spike. I'm not sure why, but it is there. And when you're measuring the distortion, especially like here in the specs, distortion, it does measure up to 20 kilohertz. That's why that spike is included in the THD plus noise measurements. It makes the numbers look a little bit lower than they actually are. So here we have 0.006, we can say 7. But if I would remove this one, like up to 17 kilohertz, this would be a much lower number, and especially the noise, because this counts together with the noise level altogether. And that's why like signal to noise is a bit lower than we would expect, and the noise is a bit high as well, because just because of this little one spike. If I would remove this spike, it would be cheating, because for other amplifiers that have a lot of harmonics here or noise, that is included in the measurement. And if I would remove this, it would look better, but it wouldn't be fair. So I just left it there. But bear in mind that all these measurements that I'm going to show you, especially these numbers, THG plus noise, they are a bit higher just because of this little spike. So let's start with the regular stuff, THD per versus level. This is between the channels. So channel 1 to 4, you can see the variation is not that big. The worst channel is number 4, which is measuring down to 0.004 or something like that. And the best one is channel number 1, which goes down to 0.002. Now, the other amplifier that I showed, the 3539, which has much more power, it is much cleaner than that. You can see 0.001 all the way down there, and it does have like 130 watts, whereas this one has about 75 watts per channel. Now, the interesting thing is, if we're going to have a look at the THD only without the noise, we can see that the THD is super low. I'm going to remove this one. It's like all the way throughout all the power levels, is 0.02 and below, we can say. So the THD itself is very, very, very low. There we go. THD versus level. 1%, as I mentioned, we have something about 70, a bit more than 70 watts. Super, super clean all the way up to 60 watts. And you can see it is very, very clean. That's what I was surprised when I measured it the first time, obviously with a bad RCA, but you can see here there's literally nothing and it's just the noise. So if you would remove the noise, THD is like this, which is on the level of a Helix DSP. It's super, super clean. Now, why? As I showed you this one, it shows 0.068, but in reality it's a bit lower. All the harmonics you can see here is below 105, which is mega clean. This is, at the moment, the cleanest amplifier that I have. Now, yes, it has a little bit more noise, slightly more floor noise compared to the others, but harmonics-wise, it is so, so low. Let me give you an example of the other clean amplifiers that I have. So this is a 305, MRB 305, which we can see has slightly higher harmonics compared to this. It is still very, very clean, 96 the lowest harmonic, but this one has lower harmonics. The other one is the F400, which is slightly newer than the 35, but older than the 305. And we can see from this one, it has lower noise, 5 decibels lower. However, it has much more harmonics. We can see they're not as high. The highest one is the third one as minus 100, the second one 104, but it has much more of these harmonics. You can see if I'm going to remove this, it's like a little forest. However, this one has much less harmonics. Now, intermodulation is, again, exceptional. 60 hertz and 7K. 60 hertz, we have the lowest one. Again, 104 and lower. There's just a second one. The third one is just barely visible. And the higher frequencies, they're literally nothing. And this is the most impressive thing. This is the intermodulation of 18 and 20 kilohertz. There is literally no harmonics. We can see here 110, and we see this one 106, this one at 2 kilohertz minus 104. There's literally no harmonics on this at the top end. This is the power supply, that's 17.8 kilohertz, but yeah, this is the cleanest that I've ever had. Now look, compared to the other amplifiers, so this is this one. This is the 305 that I mentioned it was the cleanest before, and we have these harmonics. So yeah, that's a massive difference. We have this forest. It is low. You can see it is minus 90 dB, but there's no comparison against this one. This is much cleaner. The second cleanest I had, the F400, which you can see there is a little forest. Everything is very low, but it is of a forest. But this one, it's a clean as a whistle. The multitone distortion is exceptional as well. There we go. We have, yes, we have a little bit of a noise here at the top, but look, 100 decibels, even like at the lower frequencies, 110 decibels of clean. This is mega clean, 18.18 bits. I think this is the best that I've ever seen in an amplifier. THD versus frequency. Obviously, I removed this. It's noise dominated, but the THD itself and the harmonics, look how low they are. It's just incredible how clean this amplifier is. Now, I measured all the channels and all the channels measure extremely similar. They're really comparable. Nothing really stands out. So yeah, this is a mega clean amplifier. And this is the frequency response in phase. This is 1 dB scale, down to 10 hertz, half a dB down, up to 50 kilohertz, zero point 0.4 of a dB down. I don't know. I was kind of skeptical about these old school 35 series, but apparently they're really gems. If you can get any of them, because now probably people are asking quite a lot for them, especially if they're in good condition, but I got mine for 60 pounds. I paid like a 20 pounds for the caps, which I didn't have to replace them at all, but man, this amplifier at the moment is the cleanest amplifier that I ever had for less than £100, and it does outperform anything probably like up to £1,000 in today's money. Just look how clean it is. Another thing, channel separation, because I always forget. Between channel 1 and 2 is 60 dB. Between 1 and 3 and 1 and 4, which is like a stereo pair, is minus 90 decibels, which is very, very cool. Output impedance, I did measure it as well, just to see the damping factor. So it does vary from channel to channel. Channel 1 and channel 2, you can see there's a massive difference. If we're going to take 4 ohms and divide it by 0.055, which is here, we have damping factor of 72 on one of the channels, and the other channel, which is much lower, we're going to do the same 4 divided by 0.011, I want to say, we have a damping factor of 360. So yeah, extremely, extremely good performance for this old timer. So now what I will need to do, I will need to find some fitting caps so that I could close it properly. And I'm really eager to install it and listen to it. They're going to be powering my mid-ranges and tweeters. And that 2-channel, the 3539, that is mega, mega clean, like this, more than 100 watts of power. I will be installing this for the mid-bass drivers. I will have a proper old school system. So that's it for now. Thank you very much for watching, guys, and I will see you in the next one.